Okay, so now we're recording. So I extended the due date for the Chapter 5 stuff. It would have been due this coming Monday. We could probably get it done, but I don't want to rush it. So that's cool if I pushed it back another week. We're cool? Cool. All right, so let's go through a lot of this, and we'll get mostly done, I'm sure. So we were doing this like male, female, something or other, and they were talking about a Navy something. Is that a different? Oh, here, this one right here, Navy. So before I keep going, and means to multiply. Let me see what I got here. Yep, perfect. P of A times P of B. There you go. I mean, literally, all we're doing here is multiplying. So it says, according to what you found in a previous example, being female in Navy, is it independent or not? Remember, independent means that they don't affect one another. They don't affect one another. And honestly, I gotta say, like, I don't think I saw this on the homework. If I did, I don't know. You know what I wrote for this answer here? I wrote nothing. I don't know. I actually have no answer. Is that sad? I have no idea what they're talking about. I'm gonna let it go. Is that cool? All I know is that independent don't affect one another, so whatever. Okay, brand new problem. You roll a single dice twice. So it says, what's the probability of an odd number and then rolling a number greater than 2? So, okay, we got 1, 2, 3, 4, 5, 6, and then we got 1, 2, 3, 4, 5, 6. So this is odd numbers. What are my odd numbers? Perfect. So then my probability is 3 selected out of 6 total, right? So that's the first one. Okay, and means to multiply. So then what's greater than 2? What numbers are greater than 2? Bam. 4 selected. Thank you, by the way. Divided by the 6 total. So like if you do the math there, I'm doing 3 divided by 6 times 4 divided by 6. Simplify the calculator, and we're done. It's just a calculator. Hello. Is that okay? Pretty easy stuff. Selected over total. This actually will get a little bit more difficult later, but right now it's pretty straightforward, I think. 2 cards are selecting without replacing the first card. Now that's a little different, okay? So find the probability that they're both hearts. Okay, so we're going to do hearts and then hearts, but without replacing. Okay, so shuffle, pick a card, any card. How many hearts do we have? Do you remember? 13, very good, 13. 13 selected out of a total of 52. Okay, and means to multiply. Okay, now hold on. Without replacing it, pick a card, any card, and you got a card. You got a heart. And you put it in your pocket. Okay, pick a card, any card. How many hearts do I have left now? I put the heart back in my pocket, so it's not in my deck. How many hearts do we have? 12. How many total cards do we have? Yes. See how we're subtracting 1 from it right there? That without replacing means that I'm going to not put it back. Reminds me of like these cool magic tricks. I don't know if y'all have seen those cool ones, like you pick a card and it comes out and it's like, oh, it was in my pocket and it's not anymore. It's over there. Do y'all ever see those kind of things? No? So, small story. I was like a big school event here, a college event, and there was like this magician guy, and he was like, "Okay, I need like $1 from somebody," and they're like, someone's holding up $1, like, "I got $20," and he came over, was like, "Yeah, great, man." He just took it from me. I never got it back. No. No, he put it inside something, and literally he gave me a lemon, and he said, "Cut the lemon open," and it was inside. Like my $20 bill was inside of the lemon. It was so weird. Or maybe it was just somebody else's 20. I don't know. Okay, I'm going to move on. So Elizabeth bought a box of donuts. Oh, that's so nice. And so there's 2 dozen donuts. They all look the same. 2 are jelly filled, 5 lemon, and 17 custard. So you eat one donut. You select one donut, you eat it, and then you select another donut. So what's the probability of a custard and then a lemon? Okay, so you got a big old box of donuts here. How many custards do I have? What y'all think? 17 custards out of a total of. Perfect. Thank you for your feedback. So I take that custard and I eat it. Yeah, exactly. But now I want a lemon. So then, how many lemons are left in the box? I ate a custard. How many lemons are left? 5 are left. But what's my total, though? Correct. 23 total donuts left in the box. Again, just back to the calculator, and we're good to go. 17 over 24, and then 5 over 23. I don't know. I think they just want a decimal here because it's just kind of like a crazy number. So, all right, there we go. 15% probability of that happening. Sweet. If y'all have questions, you let me know. Okay. So it says, what's the probability of a driver who is speeding gets pulled over is this much? Okay, that's definitely not the probability. I'm just going to tell you that. If y'all are driving, you're speeding, that's not the probability. It's a lot less than that. Oh, I'm being recorded. Anyways, so the probability of getting a ticket, given that they were speeding, yeah, I can see 90. Yeah, definitely a lot. So if you get pulled over, you're probably getting the ticket, right? But then you might not get pulled over at all. So what's the probability of speeding gets pulled over and getting a ticket? You see, we need to set this thing up. It's we have and that we're trying to find, but isn't gosh, if I can't just draw and, right? I can't use even one word. I'm such a math person. So there's a formula for and normally it's just multiply, and it probably will be here, but let's go back and look. You see, it says and is equal to my regular probability times the given. That's I can't even spell given over here. When it has that little line in the middle, that's the given, and this is just my regular probability. So what we're going to do is multiply again. So I'm going to say the 0.8 times the 0.9, done. 0.8 times 0.9. Y'all have fun. See you later. Happy birthday. All right. Cool. So again, just multiply. Not too big of a deal here. Are y'all cool with that? Hello. I'm going to keep scrolling. If y'all are good, I'm good. Multiply. 5, 4, 3, 2, 1. So this is the last one. Probability of unvaccinated and visits the doctor is 30%. Probability visits the doctor given is this much. So what's the probability of unvaccinated? So what's going on here is that same formula. It's basically like and is equal to your regular probability times your given. Again, these are my Chad formulas, but I think they're kind of helpful. So the and is 30%. My regular probability, I don't know. My given is the 69. So I need to solve for my probability. How would I get that probability by itself? Exactly. Divide on both sides. We're doing like the tiniest amount of algebra. Oh no. But you guys got this, right? There we go. Cool. 4347. So my suggestion, if you multiply them and it doesn't work, divide them. And hopefully it works. You get 3 options, right? 3 chances. Just saying. Is that okay? Any questions before I move on? Okay, so 5, 4, 3, 2, 1. All right. You know, because we're doing some of these problems in my algebra classes, I have this policy. It's the I do, you do, we do kind of thing. Yeah, but I don't know. How about this? I read, you read, we read. I'm joking. You're looking at this thing like, what is going on? I don't know if any of this is really helpful to you. I'm just going to move on forever. Is that okay? That was just totally a joke. Y'all don't need to read that. Okay. So 5.5. This is the last section that we have to cover, but it's a lot bigger one. It's huge. It starts tiny and then it builds up. So real quick, let me just make sure I'm not missing something here. Nope, we're good. So hey, it says to multiply. I'm just saying, it just says to multiply. So here we go. Popular brand of pen is available in 9 colors and 5 writing tips. What do you think we're going to do to find the total different types of pens? Wow! You're right. 45. Different choices, I guess you can say. There you go. 45. See, you like this, don't you? Is this good math? It's easy math. It only gets worse. It's okay. So, here's another one. So it says, hey, you get to pick one from each of these categories. How many different meals can you have? So how many main courses do I have? And then here I got 4. On this one I got, and then 2. What do I do with all 4 of these numbers? Just take a guess. Multiply, yeah, exactly. I do thank you for all your awesome feedback. Y'all can bitch in too. Yeah, it's not like you're being recorded. Oh wait, no. They can't hear you. Have y'all listened to the recordings? Can you hear you? Oh, perfect. I can start using my finger, right? See, I can like pull it out and. Yeah, I know. Like, okay, I don't know. I'm just trying to be weird with it. Multiply them. Dun 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 dun. There we go. And this is the different meals. Awesome. That's too easy. All we need to do is multiply. So these are a little bit more interesting. I would almost love to have like a you do on this, but I think it's going to end poorly. You know what? I'm going to wait. I want y'all to try it. Just try it out. It's just multiply. I'm going to go ahead and tell you the secret. It's just multiply. Tell me what you think. See if you can get that. Just try it out. You're just multiplying. That's it. And I'll wait for like a whole minute or so. It's very difficult to wait. It's okay. You're doing the math. It's going to be fun. It's math time in math class. Da, 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 da. Should I have like a theme song to my YouTube channel? You know, something catchy. What'd you get? Did you get something too? What'd you get? That was perfect. Dang, you got it, man. That was awesome. All right, now that we have to see it now, right? 4 different digits. Okay, so like when I'm going up here, it says 4 digits. So 1111, 1112, 1113, right? And go on forever. So the first one cannot be a 6. So this one's not a 6. And it says the last digit must be odd. So this must be an odd number. But does it have any constraints on these guys? So any, right? Anything? And so what are the amount of numbers that I could have here? Well, I got 0, 1, 2, 3, 4, 5, 7, 8, 9, right? If you count them up, how many total do I have there? 9. So if I added the 6 back in, how many would I have? 10, 10, and how many odd numbers from 0 to 10? Yeah, it's 5, yeah. And so you multiply them all together, and then that's how you get your answer. Doo-doo-doo-doo. Sweet. Look at that. See, y'all got this. Is that making sense? It's fun times in math class. All right. It says, how many license plates can you make? We got 6 letters when they can be repeated. How many letters do we have? 26. So 26 for the first, 26 for the second, 26 for the third, 26 for the fourth, 26 for the fifth, 26 for the sixth. Oh my gosh. Is there a quicker way to do that? Power 6. You got it. That's a lot. Oh my goodness. There we go. Boom. Not too bad in the end. Now it says 6 letters, each of which cannot be repeated. So we start with 26 letters, and you pick A. I don't know. So then how many letters do you got left over now? And then 24, and then 23, all the way down. There's not a great way to do this one other than just doing it. So here we go. 26 times 25 times 24 times 23 times 22 times 21. Whew. Still a lot. Awesome. There you go. Sweet. Any questions on that? Pretty straightforward, I hope. Okay. Are we getting to the crazy stuff yet? No? Yeah, we're almost there. We're almost there. All right. 5, 4, 3, 2, 1. You have to create a password. 4 letters followed by 3 digits. How many different passwords if you cannot repeat anything? So that would be ABCD123, right? So how many letters do we have again? 26, 25, 24, 23. So those are my letters. And then I have 3 digits. Again, how many digits do I have? Like 0 through 9 is actually 10, right? If you count them, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 10 of them. Because you're including the zeros like a 10 kind of. But if I can't repeat them, then I'd have 9, and then I'd have 8. Calculator, once again. Here we go. 26, 25, 24, 23, and then I got 10, 9, and 8. These are some really big numbers. Do you think you're going to have big numbers on the homework? Yeah, they're going to have some of these for sure. Okay. Now I'm going to tell you that these start to get fun. Yeah, fun. Yeah, in a math class, you know what that means, right? It means fun. That's exactly what it means. Gosh. So there's 12 people in a checkout line. The first person is being helped and will stay in the front. The person in the back is talking to somebody else and not actually going to stay in line. Out of the other people in line, how many different ways can you reorder them? All right, so I'm going to draw like a little checkout thing, and they're like, thank you for coming, and like, I'm glad to have been here. And so that they're already being helped. And at the back of the line, there's someone talking over here, and they're just like, hey, he's sitting down, actually. He's sitting down, and they're talking. My chairs are so terrible. I'm so sorry. Hey, I know you. So how many people in the middle? If we had 12 and they're being helped and he's talking, what do we got here in the middle? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm being lazy. I'm not giving them limbs. I'm so sorry. So, but now what we're going to do is take all these 10 people and rearrange them. How many different ways can we rearrange them? So let's go like A, B, C, D, E, F, G, all that kind of stuff, right? But then I'm not going to say A, B, C, D, E, F, G. I'm going to say B, A, C, D, E, F, G, or C, A, B, D, F, G. Does it make sense? I'm going to rearrange them in all these different ways. Like he's going here, and this one's going here, and this person's coming up front, and this one's going all the way to the back. How many different ways can we do this? So what I like to do instead is view them as empty slots. So I'm going to actually erase all my people here. I'm so sorry. Bye. So I got empty slots, like places they stand waiting, right? Like a block, a tile that they're going to stand on. So I want to put someone in here. How many different options do I have to put people in here? Like they're all standing out here. Let me put my 10 people. They're all standing outside the line. And I have to put them in. How many options do I have now? How many people are standing and waiting? 10. So one goes in there. And he's not counted anymore. I have to fill this slot. How many options do I have now? And then 8, and then 7, and then 6, 5, 4, 3, 2, and then finally only one option because he's the last person. Start multiplying. There you go. So yeah, you multiply them all out. 3, 6, 2, 8, 8, 0, 0. Yep, there we go. Ta-da! Kind of interesting. Do you think this is a good idea though? Like to take 10 people from in line and like just rearrange them? Someone's gonna get angry, huh? Especially in the parking lot. Ooh. You shouldn't have done me like that. Let me show you how the math works. There's actually, and you can kind of see what's going on right below it. It's trying to introduce us to this new concept called factorial. Now notice what I did in the calculator. All I did was this 10 and an exclamation mark, and it turned out to be the exact same thing. So that's called factorial. That's called factorial, like 10 factorial, okay? Though it does kind of look like 10, right? You're just going to keep talking, all of a sudden we got 10 and we keep moving on. No, that's, see? 10. Okay. So we were doing job interviews. This has been at least like 15 years ago, and he's now a dean. But he was interviewing for a math position, so he's teaching us teachers, you know. And he was just going, "Oh look, blah blah blah," and over here we got 10, and he just kept going. He got hired immediately. No, okay, sorry guys. I thought it was funny. Anyways, what it is simply multiplying all the numbers all the way down to 1. If you have a 0, it's a special case, and it just goes to 1. So that's kind of an oddity right there, but I don't think you'll ever see it. Okay, so let's use this same idea. It says 6 different teams. How many different ways to rearrange them? So we got 6, 5, 4, 3, 2, 1. Instead of having to do it so manually, we can use what instead now? 6! Thank you. That was great. I'm going to hire you now. That was awesome. So pretty straightforward. Now, here's a break. Here's a break in like what our concepts here. So we have permutations, and then here on the next page is combinations. And I need to kind of pair them up before we can keep talking about them. Do you see this crazy formula right here? We're not going to do it. Ta-da. Wasn't that so nice of me? We're going to use Desmos. It has it all in there for you. But let me just remind you a few things here and then tell you how this works. When you have a permutation, it is when order is important, okay? And I'm going to turn the page immediately. So that's order is important. I'm going to turn the page. Right here's combinations. This is when order is not important. So order is important versus order is not important. Okay, so those are the two contrasting things here between permutation and combination. Now, this N right here is going to be your total, and the R is your selected. So again, it's just selected and total, just like we've seen every other time. Okay, same thing with the combination. It'll be the same way. So what I'm going to do is, first off, I'm going to demonstrate or talk about the difference between order is important or order is not important, okay? So let's just say that we have people standing outside. No, they're standing in line for Walmart, right? Because we want to check out. Is order important to those people? Yeah, because they're standing in line. Hey, I got here second. You don't want someone coming in and say, nah, man, I was here just now. I'm going to take over. See, order is important to us, right? But how about this? Hold on. Don't I got some like pennies or something in my pocket? And I just start pulling out some change. Is order important? No. So like I don't have to line them all up every time. So in a way here, we have to be normal humans. I know this is kind of weird, but like some people say, no, we have to have the pennies in line. And some people say, no, we don't have to have lines in Walmart because then they get beat up in the parking lot. But anyways, Just be a normal human thinking about this. You got me? All right, here we go. So board of directors has 12 members. One person is president. We got another is vice president, another secretary, and finally the treasurer. How many different ways? So I'm going to ask before we even get started, is order important? Now I'm going to say another word for order. You already know this one. Ranking, order, ranking. Is ranking here important? Yes. President, vice president, secretary. So there's like an ordering, a ranking here, right? So I'm going to say before I even get started, order is important. And if that's the case, I'm going to use this NPR, the P part, okay? All right. I need a total and I need a selected. What would be my total, you think? Just take a guess what the number total would be. Hello. 12. Exactly. That's an easy one. Now, what would be the selected? How many people are going to be actually selected here? 4. The president, vice president, secretary, and then treasurer, right? No, it's all food coloring and stuff. Yeah. um, so exactly 4 different positions. So there we go. How do I put this into Desmos? Is I'm going to do NPR open, and then you're going to put a 12, comma 4, and then you're going to close it off. So that's Desmos right there. I'm going to just remind you. How do we do this? It's using Desmos. So let me show you what the Desmos looks like. Very simple. NPR 12, comma 4, and it does all the math for you. You're done. Literally, that's all you have to do, and you're done with this problem. Another way to get that is under like this func button. See, they have the NPR NCR right there. So you can do that also, but I just type it. It's up to you. Okay. So again, how did I go about this? I asked, is order important or not important? And then I just put the 2 numbers in and we're done. Okay, so very simple math here. How many ways can horses in a 10-horse race finish first, second, and third? So again, I'm going to ask before we even get started, in a race, the racing horse race, is the order of the horses important? Yes. So order is important. And I'm making a very important point right here. I'm trying to stress this because later on your homework, it won't be separated like it is. So order important, NPR. What would be my total for this? 10. And how many are we selecting in this case? 3, the first, second, and third. Exactly. 10, and then first, second, third. So again, this is my total. This is my selected. Desmos, and we are done with this problem. Cool, huh? Are y'all okay using Desmos for all your problems and worries will go away? It makes it way easier than doing that formula they have. No one wants to do the formula. Cool? All right, next page. Next concept, I guess you could say. So we're on the combinations. They're finally introducing, and again, we don't need to use that formula. But order is not important. So I'm going to ask the same question. I kind of think that you already got the answers here. But it says, manager accounting department wants to form a 3-person committee from 20 people. Is order important? No. If you're on the committee, you're on the committee. It's not like there's any particular way or anything. So again, I'm going to say order not important. If that's the case, we're going to do NCR in Desmos. What's my total? 20. How many am I selecting? Perfect. Total selected. NCR 20, comma 3, and we are done. The end with that problem. And this is how your homework's going to go as well. I mean, it's going to have a problem. You're going to say, is order important, not important? But it ain't done, right? No need for all these crazy formulas. Is that cool so far? Keep cruising. So this one's a little bit bigger. So it says in the lottery, we have balls 1 through 52. 6 balls without replacement. To win, you need all 6 balls. How many different ways can this happen? Okay, so first off, is the order important for this? It's hard to think about. No. Yeah. Order's not important. And you almost have to kind of take a leap of faith on that one because honestly, I don't do lottery, so I don't really know much about it. But order's not important. NCR. What would be my total? Take a guess. 52. And what would be my selected? Perfect. Perfect. And here we go. NCR 52, 6. So that's the total number of ways that the balls will come out. And you can see that like the probability of winning would be pretty small, right? So here we go. Cool. Okay, so now it's going to the next level. A bingo game has 100 white balls, and then it has 25 red balls, and each time you get 5 white and 5 red. How many different combinations? So, okay, first off, is order important? I don't really think so. I hope not. So I'm going to just go order is not important. Order is not important. Say that again. Exactly. Right, exactly. So I know that I'm using NCR in this case, right? So what would be my total? Let's just look at the white balls for a little bit. So for the white balls, what's my total white balls? Well, I'm going to select 5 of them for sure. From what? From 100, yep. So this is my total, and this is my selected. Awesome. So I'm picking 5 white balls. Cool. And then I pick the red balls. You see the and? And means what again? Multiply. Yep. And we got the red balls. What's my total red balls? Cool. And we're selecting 5 again. Calculator, and we're done. Very good. 100, 5. 25, 5. Oh my gosh, look at that number. So I don't know exactly how they're wanting to do this on the homework, because I'm going to be straight with you guys at this point. I actually didn't do the homework for this section. I know, I just ran out of time. I'm so sorry. So, like, it's going to be okay because we're not going to finish anyways. And didn't I extend the due date? If I couldn't get it done, how could I expect y'all to get it done, right? Does that make sense? Or was I just being a nice guy? I don't know. Either way. So I don't know how they're wanting to put it in. I'll go and check that later, though. I'm assuming it's not going to be a big deal, though. Cool. Mm-hmm. Yeah. Correct. Correct. Mm-hmm. True. Yep. NCR all over again. That's right. It's kind of like 2 separate problems mushed together. Very, very good. Okay. I love these problems. They're really cool. All they're asking is it a combination or a permutation? But what I also do is I actually find the answer. So how many ways can 10 people line up for movie tickets? Is order important? Yep. So order is important, and therefore I'm going to be using NPR. Now, I want to actually do this. I want to see what I can get. So I got a total, and then I have a selected. How many total people are we talking here? 10. How many are we selecting? How many are going to go see the movie? 10. I know, right? Isn't that so funny? Exactly right, 10 again. That's the point. How many are in line? 10. How many are going to go see the movie? All 10. It's in a weird situation where they don't give you 2 numbers. Like all these others have 2 numbers, you know. But this one all by itself, it doesn't have it. So just use it twice. Yeah, go ahead. It comes down to order. Right. It comes down to if order is important or not. So, like, people lined up, they want to make sure they're first. And if someone slides in and says, no, I'm first, they're going to get beat up. That's not cool, right? So, order, is it important? And would be NPR. And when order's not important, it's the NCR. Yep. So, okay, medical research needs 34 people to test a new drug. Of the 97 that volunteered, we're going to only pick 34. Is order important? No. In this case, it doesn't really matter. As long as you get selected or not, but it doesn't matter if you were first or second or fifth to get the drug. So order's not important. Yes, I am. At least I was. At least, yeah, we're good. Yeah, I was, and now I still am. Yes. So yeah, NCR, and so I need a total and I need a selected. What's my total? And selected is perfect. And there it is. So it really comes down to just the same stuff that we've been doing, just now put it in this little new guy and we're done. I know that looks funky for the answer. They don't really want us to find these answers. That's me going over. What they really want was just the NCR, NPR. That's the real answer on these. It's multiple choice. Yeah, I'm going a little I'm just going extra right now. On these questions specifically. Now back here, we actually did need to find all those numbers, but here they're just asking A or B. Yeah, I'm the one going overboard, but it's a good practice anyways. So how many different 4-letter passwords can be formed? So okay, passwords. Is the order important? Yes. I'm gonna give it away. Y'all don't have to say nothing, okay? But I'm gonna give away everyone's password. Oh, I know. Password 1. I know. But if you mistype your password and you type it like this, are you gonna get in? It's wrong. So the order of the letters is important. Exactly. So order is important. That's correct. That's correct. So that's the answer. But of course, I want to go further. So I want to see what would be my total and what would be my selected here. So how many total you think? 4 letters are selected for sure. But how many letters do we have to choose from? There it is. 26 letters. Yeah, that's true. That's true. Very true. There you go. So yeah, I go over a little bit, but the real idea was just order important or not. So Baskin Robbins is offering 31 different flavors, and it has a bowl consisting of 3 different scoops. How many different bowls? So is order important? You're scooping it in a bowl. So like, yeah, let me draw what a bowl looks like. It looks like this. And we got scoop 1, scoop 2, scoop 3. So you go in and saying, I want chocolate, strawberry, and vanilla. And they put the vanilla in first. You're like, nah, dump it. I don't want that. Right, exactly. So, and I'm going to put a spoon in it too. So yeah, order is not important. So that's NCR. And let's just do this just for fun. What's my total? And I'm selecting how many? Done. Now, I want to do a little bit of fun trickery with you here. I love this problem. It's really fun. I'm gonna change my color here because I'm now being devious. What if I didn't have a bowl? What if instead I had a cone? Let me draw you a cone, right? So then you got 1, 2, and 3. And you wanted chocolate, strawberry, vanilla. And they put the vanilla on top? No! I'm playing around. Yeah, I'm playing around. Yeah, that's true. Yeah, that's true. True. Well, thank you for laughing. No one else did, apparently. So, patients in a clinical trial taking 5 medications, they want to test to see. Oh, do you see here? It says in the various orders, changes it. There you go. So, order is important here in this case. So, NPR. Again, I need a total and I need a selected. How much total we got? Just a 5. So, you got 5 different pills. And how many are you going to take? All 5 of them. See how they did that again? So there's 120 different ways to take those 5 different pills. You take the blue one, and then the red one, then the white one, then the green one. There's a lot of different colors. Or you do it all at one time. Yeah. Yep. Is this good here? We're cool? Okay. So I'm going to keep scrolling then. 5, 4, 3, 2, 1. All right. We're in 5.5, and we are on page 102 now. Yep, 102. So this is where things get interesting. And I got to say, I think we got enough time to finish this. But then, like I had said earlier, you can come on in, man. Landon, you can come if you want. Yeah, you're fine. Thank you. So, yeah, just like I said before class, I need to leave a little early today if that's okay. So I want to do these problems. I got this one, and then I got this one and then we're literally done, okay? I don't think we're even going to get to all these because I kind of want to leave 2 as like a review next time. Maybe an excuse. Okay, so let's just get through these. And these are pretty big. So I'm going to slow down big time because it's a brand new concept, okay? So always remember that probability is selected over total, okay? So let's just keep that in mind every single time when I do this math, selected over total. So it says in a state lottery, you need to select 6 numbers from the 58. How many ways can 6 numbers be chosen from 58? Just like straight up. So is order important? Let's start with that. No, order's not important, just like we had said earlier. Order not important. And therefore, I'm going to use what? And CR, very good. What's my total? And selected? Perfect. So this is easy so far. Okay. I'm digging it. We've already done this before, basically. 40475 Again, those are all the ways to win the lottery. That's a lot of different ways there. If you purchase only 1 lottery ticket, what's the probability of winning? Not much. How do I say that in Matthew land, right? Remember that probability, once again, is selected over total. How many number things, how many cards, how many lottery tickets are we selecting here? 1. What's my total? Yeah, that huge number, right? 40 million. And that's your answer. Go ahead. Yep. This is your answer. And I'm going to try to see if it will understand this. I just don't think it will. See, that's kind of like junky. I don't know what they're going to want. So I would just leave it alone right now. And if they ask for scientific notation, which we'll check later, no. Yeah, it's basically it's like 000000247. That's what they're trying to say. It's crazy. So if that's on the homework, I'm gonna go and look at it later. Again, I didn't do that, but I pushed the due date back, so be happy with me, please. Yay. Anyways, so now it says, what happens if I had 100 tickets though? So how many am I selecting? And then I have the same total, right? How do I reduce this one down? Slowly. It might work in Desmos this time. Let me try. So I'm going to do 100 this time. Yeah, same kind of thing. Oh, there's a fraction button over here. Hey, look. It changed it to a simplified fraction, I guess. I don't know. I don't know what they're wanting. They might want this. They might want that. I can't remember. Yeah, I guess. It just didn't change. See how like, well, that was that, and you see it's like the same, but this one reduces because it's got a number in common or something. Yeah, 2. Basically just a 2. Very good. Are y'all okay with selected over total? Okay, now it's going to get even more meaty. Okay, so there's a little bit more in this one. A shipment has 120 fasteners, but yet 4 are defective. So they just got a big old box of these things, but we know 4 of them are messed up. And they're just pulling 5 of them out randomly and seeing if they're defective or not. Okay, so what's the probability of exactly 1 being defective? Okay, so big old box, and I'm pulling 5 of them, and I'm going to test them. What's the probability of one out of those 5 being defective? Not much, right? It's going to be a very tiny number. But let's see how we're going to approach this problem. What I do is I split this up into kind of like 3 categories, okay? 3 different boxes. And what I'm going to do is we're going to do defective, and then we're going to do not defective, and then we're going to have total. Okay, so this is how I split it up personally. I have a small question before we keep going. Is order important? No, order's not important for the whole problem. Order not important. And so if I'm going to use NPR or NCR, which one? Yeah, the NCR. So NCR is going to be the thing that I use all throughout this problem. So what I'm going to do right now is put a little C in each one of these boxes. Okay, because I'm going to use the NCR thingy. I just need to fill it in with each total and each selected. So here we go. I'm going to ask you, what's the total? Like every one of these on the side is a total, and every one of these here is going to be a selected. Okay, so what's the total defective? 4 total defective. How many am I going to be picking out and inspecting that are defective? Well, I have 5 total I'm picking out, but how many of them are defective? See that? Exactly 1, right? See how they're going to tell you that part? And they're going to change it as we go. So 4 are in the box that are defective, and I'm saying, what's the probability of me pulling them out, and I'm going to get only 1 of them in my hands out of the 5 that are defective. Okay, the same thing here for not defective. How many not defective ones do we have? 116, exactly. 120, and we're removing the 4, exactly. If 1 is defective in my hands, I'm supposed to have 5 total. Then how many were not defective? Exactly. And so here's let me erase this a little bit so I can get a little bit more room. I'm going to show you another little trick. You see, the total is like the grand total in a way. Grand total, I'm supposed to be having 120 different fasteners, and how many are in my hands? 5 of them, exactly. See how these second numbers add up? Yeah, and then the same with the first numbers as well. So this 4 and the 116 make a 120. So it's like kind of like the grand total box in a way. Let me put it all together in the calculator. That way you can see what I'm doing here. So NCR 41, NCR 116.4, NCR 125. We got a number, and that's the answer, and we're done. We're going to repeat this process many times, and not just today, but also on Tuesday, because I want to make sure that I cover this topic again. Okay, it's an important topic. Maybe what I'll do, if we have time, I don't know how far we're going to get here in a few minutes, but maybe we'll do like one of the. I don't want to do that. It's fine. This will be the last problem of the day. Is that cool? Whoa. Okay. Yeah. Did you have it? You said you had it during the summer with the Newton Alta. Oh, okay. Okay. I get you. Yeah. So it says all of these inspected ones are defective. So hold on. I'm going to pull out. I have 5. I'm going to pull out 5, and I want the probability that all 5 of them are defective. Think about this for a second. I have a big old box. I'm pulling them all out, and I said every one of them somehow is defective. Already, that's kind of low probability, right? But if you look, all 5 of them, are defective. You see it? The little switch they're trying to do there. How many are actually defective? 4. So I'm saying, what's the probability of 5 defective? 0. You can't. They're trying to get you. They're trying to get you. You see that? Watch out. Watch out. Yeah, I know. I know that sounds silly, but like literally that's what they're trying to do here. Okay, what's the probability of none of them being defective? That's okay. We can do that one. So I'm going to do the boxes again. I'm going to make them a little bit bigger, I think. Okay, so I got a C, and a C. So this is defective. This is not defective. So how many total defective that we have again? What's my total defective for this problem? 4. How many am I supposed to be holding in my hands right now? 0. Very good. Okay, non-defective again would be 116. How many should I be holding in my hands? Again, I'm picking out 5. Yeah, exactly 5. And remember how these add up? Because this is the grand total. This is the total box. And then those other ones add up. Yep. Here we go. So NCR 40 times NCR 116, 5. Oops. And then NCR 120, 5. Awesome. 84159. There we go. Sweet. And if you remember from last time, Chad gets this one wrong all the time. We're going from none to at least 1. Isn't that the opposite again? What's the opposite of none? Is at least 1. So what's the opposite? How do I get the opposite of this thing? 100 minus. Exactly. You got it. If y'all remember, I remember at least that I was getting this one wrong a lot last time. But it happens, you know. It's sometimes a little confusing, but that's what we're going to do on this problem here. Okay. I promised you it would be the last one of the day because I do have to get going here. But what I'm going to do, again, starting Tuesday, I'm just going to cover these again, okay? And I'm going to go through the homework because I really need to make sure the homework is okay. You get me? And then we'll start on the Chapter 6 stuff, which is not that bad. It's actually shorter than the rest. Any questions? We're out early today. Isn't that cool? Thank you, guys. Y'all have a great weekend.